We are on session 6, everyone. Hey, Jocelyn, how you doing? Say, Gretchen, before you go today, can you see me? I want to make sure I get all your information so I can get you signed up and get there. Perfect. Thank you. Actually, I'm just going to check this out. So everyone, this is Vanna Benson. She is a flight instructor. She's been helping us out with with SIA and also getting the scholarship set up with the EAA. So remarkable resource, great instructor. She is here today to get you guys signed up for the Young Eagles program, which is part of the Experimental Aviation Association, or EAA. The Sporties program is free to you. So it's like $300 or something.
Yep. Normally $299.
Yep.
Yep. So all that you're doing with laying the great foundation about the written test prep, they have an actual test prep bank. So you can go from this class, start delving into Sporties, and then help you get ready when you're ready to actually take the FAA written pilot.
It's awesome material, way better than what
Great videos.
Yep. I still want you to use our quizzes.
Absolutely.
I want to make sure you guys are following along, but the Sporties materials are just top notch. And you can use it on your smartphone, unlike what we have on SIA. So if you're out at the lake or something like that, relaxing, you can bring up your smartphone, start studying. And they've got great quizzes. You can do quizzes around areas that you're efficient in, which I highly recommend. Take a test and find out what you're not so good in, and then work on that. But their software is designed to help. So, in any case, one by one, if I can have maybe starting with Max, if you want to go first, and then Ivana will get you signed up for the Young Eagles and get you on the Sports program. And then at some point, we'll have a couple of days here. I'll fly you guys and whoever other pilots that
Sure.
to help out with it. But I'll take you up in either the 150 or the chief or the twin branch, and then what other things after your discovery flight there, and then that would be part of that. So, anyway, so Max, why don't you go first, and then Max, when you come back, or about if you just have the next person in line there, just keep going down the line, and we'll get everybody signed up for that. So, all right. And what we're gonna do, we're gonna dive in right here. So, I've got a few minutes left. Before we get started, does anybody have any questions from last week at all? The session at all last week? Ethan, how you doing? All right, so we are on session 6 this week. So this class, this one's going to be easy. Okay, so we're talking about basically controls in the aircraft. We've already gone over a lot of this stuff. But we'll kind of refresh your memory on it. We've got a new class member here, Gretchen, is going to be joining us. So you'll be catching up and stuff like that. If you have questions, I'm sure Cadence can help out with stuff. And if you're not, always hold me. Just email is the best way. So in any case, we're going to be talking about the connections in the aircraft and everything. Hey, Gabe, how you doing? How the controls work and things like that. But I think you guys already know all this stuff based on what you guys have, told me in the past, what you've said to me. So I think you've got it. But let's go through this. Let me just switch to our. Yeah. All right. So just as a refresher, let's bring up our. Right. So zoom in a little bit here. Okay. So anybody tell me what those control surfaces are? Ailerons. Okay, so these are the ailerons. And what do they do? Roll. They cause the aircraft to roll. All right, here's a trick question for you. and you'll probably get this better. You'll actually get this right more than some existing pilots. So, what causes a plane to turn? What's the control? What's the control? Elevator. That's what I'm looking for. The elevator is what causes the plane to turn. Remember we talked last week when the aircraft goes into a bank, it doesn't turn just because you bank the aircraft, right? What causes it to turn is that elevator that causes the lift it lifts the aircraft into the turn. That's the way to think of it. So when anybody asks you what causes an aircraft to turn, it's always the elevator. And you can say pitch as well, yes, because you are pitching into the turn. That's the other way of doing it. But what I think what most instructors are looking for is that elevator. So you pitch into the turn. Because again, all you're doing when you go into a bank like this is you're just banking the aircraft. That doesn't cause the airplane to turn at all. It needs some force to push it into the turn, and that's the pitch or elevator that we've got there. Okay. All right. Good. All right. So let's see. Here. Okay, what are these that are slowly dropping down? What are those? Flaps. Yep. Hey, team, how you doing? All right. And some aircraft, the flap actuators on aircraft they could be like an old style brake handle that you pull up one notch at a time. Some of the older aircraft, they'll have like a little bar on the floor of the cockpit. You just press a button and pull it up like that old style brake. I don't know if you've ever seen like an old car. They have like a little push button. You lift the lever up and then it drops down a flap. I love those, by the way. But a lot of the newer ones have electric switches in the cockpit. Some of them you just, like in this case, what I'm doing is I'm holding a button down in the cockpit. Let's switch to that. So in the cockpit, the flap switch is, it's right here. There's the flaps right there. And what you would do is you'd pull that down. You can see that right there. That's there. So that right now the flaps are dropping. You can see that actually this right here, that's the flap indicator. That tells you how many degrees of flaps you have. This goes up to 40 degrees of flaps. So what you do is you put that little lever down there and you can see the little indicator up in that yellow area there. It's showing that we've got 40 degrees of flaps. If you want it to go up, you just flip it up like that. These were older style electronic activated flaps. The newer ones, they actually have detents. So they have a detent for 10 degrees, a detent for 20 degrees, a detent for 30, and so forth. So it's a little bit easier to drop the flap, so you don't have to hold it down for X amount of seconds to get it there. The problem is with those old flap switches like this is you have to count them out. Whereas the newer style flaps, it's basically you just set to the position and the flaps just automatically round down to that 10, 20, 30, 40 degree position. So that's the flap switch right there. Bring that up and let's see if I go outside there. All right, so there's flaps. All right, and what's this? Elevator. Yep. Okay. And what does that cause us the plane to do? Pitch. Yep. So when we pull back on it, it's going to cause the plane. Let's move this down here. If I pull back like this, what is the plane going to do? It's going to pitch up and go into climb probably, as long as you've got enough airspeed. Right. And then this obviously is pitch down. Yeah. Okay. What's this surface right here? Control surface. Yeah. What's that? The yaw. Yeah, it controls yaw. And what is it called? Rudder. Yeah. Just like in a boat. Same thing. You steer it one direction. This over here. Let's go right back here. So see if I swing that way, that the plane is going to yaw. So here's our plane. If I do a rudder like that, the plane is going to yaw in that direction. Here, yaw like that. If I do it like this, if I push on my right rudder pedals. Now these are controlled by rudder pedals inside the cockpit. Let's take a look at those. I don't know if I've showed that to you before. So Right, so let's look at the rudder control yoke. These are the rudder pedals, and they look like brake pedals on a car, but there's a left one and a right one. When you push on the right one, you can see that pedal move in there. Notice how also on this plane, you've got two sets of them, one in the pilot position and one in the co-pilot position. Well, this is a training aircraft. That's why they do that. A lot of training aircraft will have the controls on both. You know, some other aircraft, they may not have the same thing. Most aircraft, though, I don't know if there's any that don't have a control on the side. Maybe some older aircraft only have the controls over here, but the vast majority of them have a pilot set of controls and then co-pilot set of controls. But here that you can see that they're linked, and that's just with pulleys. That's using pulleys, and we'll get into that here in a second. So again, if I want to do right rudder, plane to do the rudder like this, for instance, I'm going to push on that right rudder pedal. And see how the left rudder pedal comes back to do it? They're linked together. So, I mean, if you imagine in this aircraft, you've got a long cable that runs from the foot pedals up here and runs all the way back to that rudder. And those are connected. And it's just a loop that goes through these two rudder pedals up here. And as you apply rudder pressure to, let's say the right rudder here, it's going to cause it to do that. So if I go outside the aircraft, hold on my right rudder, you can see the rudder swinging to the right here. The other thing you'll notice about the rudder pedal, and this is true of most training aircraft, watch the nose gear. See how it turns the nose gear right there? Oops. It's kind of hard to see this thing. Push it all out there. Let's go to the front here. Okay, so there's our nose gear right there. So I'm just going to apply right rudder pressure. See how it turns the, I don't know why it's going back and forth. Let me just, something with the sim there. It's trying to turn right there. It's not staying very well. So, but that's a linkage from the rudder pedals here to the nose gear. And that's so you can steer on the ground. Because obviously, when you're on the ground and you want to steer and you don't have any air flowing over your rudder, the plane's just not going to steer at all without having some sort of friction on the ground. And that's what that does. And there's a linkage again in the cockpit here from the rudder pedals down to this. That same linkage also goes all the way back to the rudder in the back of the plane there. So, okay. So that's rudder controls. And they're basically, in like most training aircraft, they're just cables. That's all it is. Cables and pulleys. Okay. All right. So, like I said, we've probably just covered everything in this chapter, but let's go through it. So, one of the things that we haven't covered yet, haven't even talked about, is the an engine, how an engine works. So, we'll dive into that here in a second. Let's go over this again. This is what a typical pulley system looks like. This is a control stick. You could put a rudder in there, or I'm sorry, a control yoke in there. It would be the same thing there. It would be like having a yoke up here. But there's your pulleys. That's all the pulleys look like. You've got like a cable that runs between the pulleys, and when this little actuator pushes the pulley this way, this pulley responds in the opposite direction. It's going to pull this way, which causes the elevator to pull down there. So, and it's usually a series of push rods and cables that do connect all that stuff together. So there are what we call pneumatic and hydraulic systems that do essentially the same thing. So when you think of hydro, think of fluid. Okay, we've all heard the term hydraulic. That's referring to a fluid. So what a fluid is, it takes the place of the cable. What you're doing is you're displacing, fluid in one piston, like here, with another one over here. So it's actually causing this. If I take out fluid here in this piston right here, it's going to cause this piston to move over this way or something like that. That's you don't have to know a lot about this for the test. Don't worry about it. The FAA doesn't get into hydraulics or pneumatic systems. They just want to make sure that you understand how a plane flies, you know, what are the control surfaces that cause it to fly. So, but this is a typical system. Pneumatic systems are controlled by air. Okay, so you've got liquid, which is hydraulic. Think of hydraulic fluid like in tractors. There's hydraulic fluid even in cars and stuff like that. So it's just another way of transferring energy from one part of an aircraft or car or whatever it is that you're using to another. And pneumatic does the exact same thing. It's just air pressure instead of fluid air. Okay. All right. And I think you guys, oh yeah, this is the helicopter diagram that they have in there. We don't really have to get into this. You're not going to have to worry about this on the written test. But they have, if you're interested in it, for a helicopter, things are a little different. So they have this. They actually, has anybody ever seen a helicopter? Actually, been in a helicopter in here? Okay, you guys have. So, did you see the controls inside the helicopter? You know, there's two controls, right? They've got one on either side. They've got a lever that's called a collective, and that changes essentially the pitch of the blades of the helicopter itself. That causes the helicopter to rise up. As long as you've got enough power. You know, if you don't have enough power, the blades are going to stall. The cyclic is going to cause the helicopter to bank left or right or whatever, or forward and back. And then your rudder pedals, they don't call them rudder pedals on a helicopter, but they do essentially the same thing. They control the yaw of the helicopter, and they control it by basically a prop in the back that rolls sideways. So if this is our helicopter right here, if you press on the anti-torque pedal, the right anti-torque pedal, it's going to cause the helicopter to turn that way. Okay, and what it is, there's like we've all seen helicopters, they've got that prop in the back there. So what it does, it either releases pressure so that it doesn't hold it. Like if I'm flying in this direction with my helicopter, if I release, or apply pressure on my right rudder pedal or anti-torque pedal, it's going to cause the helicopter to bank to yaw in this direction. So it's just controlling the amount of thrust that this is producing right here. And that's, you could probably guess, this right here. It spins at a constant rate, but the pitch on that propeller, it's kind of hard to see there. I don't know if they've got a better, yeah, they don't. Just think of this as it's like a aircraft propeller, but it's got a variable pitch on it, so you can actually control the pitch of the propeller. So like this right here, this is a fixed pitch propeller. There's, the pitch is locked in place. It's just welded right there. On a variable pitch or constant speed, they call it constant speed propellers. These blades can actually twist. They can actually turn. There's an actuator in there that causes it, and that's what's happening here. So they can change how much thrust that's producing. That's how they get it to yaw left and right. Again, I don't want to spend a lot of time on that because it's the FAA doesn't. They're not concerned that you know that much about it. So, all right. So, and again, we've talked about this before. There's different axes of control on an aircraft. So they've got all the answers right here. So elevator is on the causes the aircraft to pitch. We've already talked about that. And then we've got our vertical. Well, actually, they don't have the. I guess they do. Yeah, they talk about the axis rotation there. So this is a good chart if you ever need to use it on short page. That is 6.3. 6.3. Okay. Okay. So you can again, you could just go over this right here. This is stuff that we've already talked about. So the aileron, it causes the plane to roll back and forth. Axis of rotation for the aileron is longitudinal. So the longitudinal runs from here. Okay, so the longitudinal axis is like this. It goes through the tail of the aircraft to the nose of the aircraft, right? And it rolls around that axis, around the longitudinal axis like this. There. So Okay, and then lateral access, that's this way right here. And oops. And what is our control for the lateral axis? What causes the elevator and pitch? Yeah, yeah. Again, I think you guys got this, but gotta go over. And then vertical, obviously, is yaw and directional control there. So, right, perfect. All right, so this is a new concept that we haven't talked about much. So in turns, let's actually, I think maybe we went through this once. I may have hinted at it one time. Let's see. All right. When you go into a bank on a turn, there is one thing that I briefly touched on. I said we'd get into it a little bit later. Now is the time we're going to get into it. So let's say we want to go into a left bank. So you're right here, you want to go into a left bank. So on your side, it's going to go like this, right? Okay. What do we have to do inside the aircraft to get it to go into a left bank? A little bit louder? Yeah. Yeah. Got it. Okay, perfect. So what's that going to do when we take our control yoke and move it down? What is it going to do to these ailerons? Is this one going to go up? Is this one going to go down, or vice versa? We know that ailerons act opposite to each other, right? So if I go like this, if I want to bank to the right on your side here, these are the controls right here. We go like this. Then same with the left. We're going to go like this. So in a left turn, I just gave you the answer. What are the ailerons going to do? What is this one going to do right here? What's that? It's going to go up. Okay. What's this one going to do over here? Down. Okay. So because of that, this right here is actually producing a lot of lift. What happens when we produce lots of lift? We create drag. Yeah. Yep. And when we bank like this, all right, if I'm banking this way, because this aileron is down, we're generating more lift, there's more drag on this, and it causes the plane to actually, the nose of the aircraft to actually swing a little bit in the opposite direction of the turn. Okay, this is a very important concept because this is something you will get tested on. So that's called adverse yaw. Okay, so the plane, and you can do, have you done it, Jace? Have you done turns yet on there? Yeah. Did you notice this? Yeah, you did. Okay, good. Perfect. Yeah. So and okay, so you just said the next thing I was going to say. So we counteract adverse yaw with, can you guess what we'd use? What control we would use? Rudder. Yep, rudder. So we're going to actually counter it by using a little bit of rudder into the turn. So in this case, we're going to use a left rudder. We want to get it started. But once the turn is set up, these controls actually, we turn them back to neutral. And then the plane, we don't keep the rudder in that throughout the turn. That's a common mistake with even experienced pilots. Sometimes they'll leave the rudder in there for the full turn, and they're actually operating, the plane is kind of skidding into the turn or slipping into the turn. So it's just, all you're doing with the rudder is to prevent that adverse yaw when you go into a bank. Like go this way, again, this aileron's coming down, this one is going up. So we have lots of drag on this side right here. Because of that, the plane is, instead of turning this way, it's going to yaw this direction. It's still going to bank like this, but it's going to yaw like this. So we're going to be flying like that. We need to get that rudder to balance that out. So when we feel the seat of our pants, the center of gravity is below us instead of us sliding over to one side. And you can tell when somebody does it. We call it a coordinated turn. So a coordinated turn is one where here, I'll show you. Coordinated turn. See this little instrument right here? This is probably one of the most basic instruments, but it tells you a lot about the quality of your turns. All this is right here is a curved tube of glass. So we can see through it. There's a little black ball in there. I don't know if you can't really see it, but there's a line right there, and there's another line right here. I'm zooming a little bit more. Just barely made it out there. This is what we call a turn coordinator. it's a combination of a gyro, but it's also this curve too. But again, it's probably the simplest instrument in the aircraft, but it tells you how good the quality of your turn is. So if we're flying, let's say we're flying straight and level, like this, all right, but we've got our rudder turn like that. If we hold it straight and level like this, the plane is going to fly, and it's going to fly through the air kind of like that. Okay, what you're going to see is that ball is going to be going to the outside of the turn there. So this ball is going to swing way over this way, over here. That we want to get that ball in the center between those two lines. There's a line right there. It's hard to see there, but there's a line right there and a line right there, and we want to keep that ball inside that turn. That's what that is telling us, is that our center of gravity is right below us. Okay, and now we know that we've got a coordinated turn or a coordinated flight. There may be, if you're doing a long cross-country flight, you may see occasionally that ball will swing over from one side to the other. It usually means that maybe one tank has drained more fuel than the other. So the plane is compensating for it. So you have to adjust. And most aircraft do have like a rudder trim or something like that. There's a lot of the small trainers don't, because they're so light, and they typically drain fuel from both sides. So, but yeah, that's what that's for. That's part of the turn coordinator. So, and it's actually called an inclinometer. It's actually the technical term for it, but it's part of the turn coordinator. There's two instruments in here. This one is the part of the gyro there. Tells us our rate of turn, and then this just tells us the quality of the turn. So, and actually, what I can do, this is good enough to maybe just demo. Let's get it up in the air here. All right, let's see if I can actually fly this thing today. Right, see, it wants to turn left. I'm applying right rudder now to keep it on that center line as best I can. We're in the white arc now. Can you see that? It's kind of hard to see there right now. We're here. Oops. All right, so take a look as I do my turns here, just take a look at that ball there. All right, so you can see the ball. You see how it's kind of swung over to one side there? So a little bit more here and see this. Okay, so it's right now we're slipping to the outside of the turn, and now it's on the inside. Okay, so right down here, you see how the ball is kind of tilting to one side. So I'm not really in perfectly coordinated flight. If I really want to get it in a coordinated flight, we do this thing called step on the ball. So if you see the ball swing over to the right, you step on that side. So I use right rudder. It's called step on the ball. So if you see the ball over to the right side, I just apply right rudder and watch what happens to the ball here. See how it falls right in the center now? So that about right, I'm doing very good. There, that's coordinated flight right there. Of course, now I'm not flying straight and level. So a lot of times in flight, that's going to be moving around. It's just like a level. Have you ever seen those little bubble levels? They do the same thing. They kind of flop around a little bit. You can't help it. When you're in a plane, it's going to do that. The ball is going to swing back and forth. But what you want to do when you go into a turn, you want to make sure that that ball is centered. So let me show you a turn here once. So I'm just going to do a bank to our left. We'll see what happens here. I'm not using any rudder. Yeah, it's not too bad, I guess. Straighten out. And obviously, in a real aircraft, it wouldn't be this jerky right here. I still haven't recommended training since it was there. But yeah, if I go into a turn, the ball is going to, either sink one direction into the turn. Like in this case, I need to apply a little bit of left rudder, right rudder. Sorry. Step on the ball here. We get that ball in the center of the those two little marks there. So let's see. Yeah, the one thing about the simulators, it's hard to see the adverse yaw. I'm going to try it once and just so you can actually maybe see what it looks like. It's again, it happens pretty quick. So let's go here. All right, so I'm just going to do it back. Oh, we got our flash. Okay. All right, so what I'm going to do here is I'm just going to go into a steep bank here. This is not the best place to do this. Let's do it right here. Let's see if we can actually see the adverse yaw. I'm not going to touch the rudder pedals at all. So I'm just going to go into a turn. Yeah, you can't really see it. It's you would feel it in a real aircraft. You'd actually feel the adverse yaw. It's when you first turn in there. Let's try like this was. You can kind of see it. Did you guys see that there? Okay, so I'm gonna get it to go to a bank. Watch what happens. There's gonna be a slight lag on the upper wing on this wing right here. It's not gonna see how there was like a little lag there and it kind of caught up to it. And again, what the rudder does is it eliminates that little lag that's there. So it's only when you go into the turn that you're going to be applying the rudder. And that's more of a practical application of it. So when you're up flying with your instructor, you'll know you want to apply a little bit of rudder when you go into a bank. You want to get that, you want to kill that adverse yaw there. So, all right, so it's called adverse yaw. It's not the same as like the left turning tendencies, which we discussed last week. That's something else. So, okay. All right, that's what this whole diagram is describing here. We're producing lots more lift on this side. Because we're producing more lift, there's more drag. It causes that wing to fall back, whether it's left wing or right wing, just depends on which way we're turning. The plane will always turn in the opposite direction. Again, and you will get tested on that. There's questions on that. So, all right. So, in flat or ailerons here, we've already discussed this. We really don't have to go into it. I think you guys have got this down. So the ailerons work opposite of each other. Like, when one goes up, the other one goes down, vice versa. Now, one thing you can do, if you want to impress your instructor, when you go to check your controls, take your hand, put your hand on your control yoke, stick your thumb up, okay, and then turn the control yoke. And the direction that your thumb is pointing in is the up elevator, or the up aileron. That should point to the elevator or aileron that's up. It's not enough just to check and see that the controls are free and correct. So you guys haven't gotten into this yet, unless you've gotten into flight instruction. But one of the things that your pre-flights, your instructor is going to expect you to do is to make sure that the controls are free and correct. Okay, two terms there: free. I can move my elevator back and forth without it winding up someplace. Because every now and then it does happen. It's very, very, very rare. But maybe a stone or something gets stuck in there, a stake or something like that gets stuck in the pulleys, and all of a sudden you feel you can't pull the elevator all the way back. That would be disaster in flight, right? You have to have control of the aircraft, control yoke. So if you have your thumb up either right or left and you rotate your control yoke this way, you should be looking at the aileron that's lifted up. It should be like this. If I'm doing if I take my control yoke and swing it over like this aileron should be up. And then I should look at my opposite aileron and make sure that that is down. That's the correct part of it. So it's free. The control is free both ways and correct. The ailerons are up and down on both of those. Okay. We do the same thing with the elevator. We check that. If you've got a rear window on the aircraft, you can look out just to make sure that the elevator is working right. Same thing with the rudder. We run the full motion of the rudder to make sure that we've got full, it's completely free. The cables are completely free on there. It's a little bit harder with the rudder because it is tied to your nose wheel, and there's some friction there when you apply full rudder on especially if you've got a heavy aircraft. It's going to be a little bit more difficult to do. So, all right. So anyway, you got that. Any questions on that? Yeah. And these are the typical ailerons you're going to see, and what they're really describing here is the how the air flows through this. A lot of the Cessnas and Pipers as well. There's a large gap. So this is a cross section of the wing right here. And then this is our aileron right here. You can see as the aileron lifts up, in this case, the rear lifts up, the air kind of flows through there. That just helps it produce a little bit more lift, negative lift in one direction or positive lift in the other direction. So like this, it's positive lift here, pushing that up, and then this one is obviously producing lift in the opposite direction, or creating drag or whatever it would be in there. So so it assists in the turning of the aircraft and the banking of the aircraft. And again, nothing unusual here, guys. You know all this stuff with the rudder deflections. There's a typical diagram for the control yoke, the linkages. Oftentimes you'll see springs in there, and you don't have to worry about this stuff. That phase not. You don't have to know about this stuff, at least as a private pilot. You don't have to know how it connects to it. You just need to know that the control yoke controls ailerons and elevator. And then the rudder pedals control the rudder itself. Okay. This is okay. So this is kind of interesting. This is an aircraft that uses what we call flaperons, and actually flaperons, like the name sounds, it's a combination of flaps and ailerons. So it doesn't have two distinct two different controls for those surfaces. So let's go back to our plane here. So on this aircraft, when we look at it, kind of hard to see. Let me see if I can drop. I guess I can. So this is a flap right here. This is a flap. We know that they're linked and they drop down together. It's kind of hard to see, but this right here is the aileron. And oh no, it's just not paused here. So I'm just going to drop the flaps there a little bit, so you can kind of see the distinction between. Let's pause it right here. So there's our flaps. They both come down at the same time. There's our ailerons, one right and left. With flaperons, this is one solid surface. And what they do is they combine the flap control with the aileron control, so that these control surfaces do kind of the same thing. So if you've got so if these are the flaperons in the back of the aircraft, let's say like this here. So let's say this is our aircraft. If let's say you drop flaps, the whole flaperon moves down a little bit, but you can still control the bank of the aircraft with the ailerons. So it's a combination of flaps and ailerons. That's what a flaperon is called. Does anybody know what an elevon does? I want to take a guess what an elevon. Think about the term elevon. Yes. Okay. Now here's for bonus points. Can you figure out if are there any aircraft that you know that would use an elevon? It's an elevator and aileron combination.
Assume something that is small.
It could be. It could also be very large. I'll give you a hint. Here's the fastest aircraft in the world. SR-71. Okay. If you look at the SR-71, I don't know if you guys have ever seen an SR-71, but it's got what we call a delta wing configuration. So there's no like separate wing in the front. It's just a kind of a one long wing in the aircraft. Has a tail with rudders, but there's no like wings with ailerons on them. It's, the flaps and ailerons. The elevator and ailerons are in the rear surfaces. So they do the exact same thing that a flaperon would do. But because it's in the back of the aircraft, it's called an elevon. So, and again, you don't have to worry about that for the FA test. They're not going to ask you about an SR-71 or anything like that. But it's just good to know. All right. So let's see. Any questions on that flaperon? I don't think there's any questions on the flaperon either, but you should be aware of it. So, all right. Again, you guys all know this stuff right here. This is the pitching motion of the aircraft. We did talk a little bit about the force, and we're actually going to get into that a little bit more. This downward aerodynamic force. We're going to talk about that a little bit more when we get into weight and balance. next chapter. Let's see what else we got here. Okay. So this right here is a what they call a T-tail aircraft. And most aircraft have the elevator in line with basically the wings. They're really close to the wings like this. I don't know if you can see that there. They're almost, in line like that. But the T-tail, the elevator is actually on the top of the aircraft. So instead of it being down here, a T-tail, the elevator is up here. It'd be the horizontal stabilizer is going to be up here. Or, yeah, the horizontal stabilizer will be up here instead of down here. It does have slightly different characteristics. The whole idea behind a T-tail aircraft is that they're a little bit more controllable sometimes in certain situations, a little less drag there. But it can also it can create problems with stalls because when you get close to really slow speeds, there can be some issues there with that. Again, I don't think there's anything on the FAA test on that. Just know that if a T-tail aircraft is going to have the elevator up here as opposed to down here. As you can see, there's no horizontal stabilizing surface down here. It's all up there. So I think they go into that a little bit in the book. Just take a look at that and see there. Yeah, this would be on 6.6, I believe. Yeah, they talked about it there. You'll see this in like the, what is it? I think Piper Arrows, they have T-tails, but there's not a lot of aircraft that have it. Some of the faster jets, you'll see the T-tail, like I think there's another one on page 6.7. What's that? Yeah, Citation, I think, has the horizontal stabilizer on the top. And I think there's a lot of other jets that do as well. And they do that mostly for performance, but there are some side effects of it. So so that's that describes a T-tail on there. Yeah, so I guess the big thing here, they're saying when flying at a very high angle of attack, so if the plane is flying at a real high angle of attack, because the air is hitting this wing right here, it's creating those little eddies, right? We know when the aircraft is approaching a stall, the wing isn't producing sufficient lift. You get a lot of turbulence back here, a lot of burbles of air. What happens is it doesn't hit that surface and it becomes a little less stable. And they describe it in the book. They say flying at very high angle of attack with a low airspeed and an aft CG, that T-tail aircraft may be more susceptible to a deep stall. And that's meaning that the airplane is going to, stay in that stall for a long period of time there. So, and again, that's one of the things. And again, I don't think that's on the test, but something you should be aware of there. Okay. Let's see. Let's go here. And you guys know all this stuff already. The controls elevator. You know what controls the elevators, the yoke, pushing it back and forth. I do the same thing on the control yoke. If I push the control or the stick forward, and some aircraft that have sticks, you're going to go ahead and the plane is going to move down. Same thing. So they work the same way. A stick and a control yoke is going to work essentially the same on there. All right. This is something that you'll see in a lot of Piper aircraft. They have, there is a what's called an anti-servo tab. Can anybody guess what that is? This is the stabilator, we call it, and it's in the back of the aircraft. Can anybody guess what this does? This anti-servo tab.
It's more like a trim tab, like it kind of corrects possibly.
Actually, you're right. It's a trim tab. That's what it is essentially. I don't know why they call it an anti-servo tab, but it's designed to adjust the trim of the aircraft. So it runs pretty much the full length. If you ever see a Piper, just take a look at the tail and you'll notice that the trim tab runs the full length of that. I think it has something to do with the fact that this is a stabilator, and that's why they call it an anti-servo tab. But essentially, you've got your pivot point right here. This red line right here is our pivot point right there. And as I pull back on the control yoke, the whole assembly is going to bend into the wing like this. If this is our aircraft right here, this whole surface right here is going to bend, not just the elevator itself. That's called a stabulator. When it's all fixed like that, we call it a stabulator. And again, you'll see it in a lot of hyper aircraft. Most of the Cessna aircraft, they have, fixed horizontal stabilizers, and then the elevator itself. Yeah. Great. This is a Piaggio Aero. Is that what it's called? It's a pusher aircraft right here, and it has a unique configuration. This isn't really a good shot of it. It's hard to see, but they've got these two little wings in the front. Does anybody know what that is called? Canards. Yeah, it says right there. Okay. Yeah, they're canards. We saw this back. I think Dick Rutan created the. I can't remember the name of the aircraft. It was a front canard aircraft. It was a kid-built aircraft. You could actually build it yourself. I know a couple of people that have built them around here. They're very fast. But what they are essentially is they have kind of a delta wing and a prop in the back of the aircraft. And then they've got these two little winglets in the front, or these wings. We call them canards. Canard, interestingly enough, in French means little wing. But what they do is they help prevent you from getting into a stall. Because they're so small, that's what controls the pitch of the aircraft. The canard does. That's your elevator right there. Well, you can only with that small of a wing, they don't have much authority if they don't have a lot of air flowing over them. Okay, so if there's not much air flowing over it, the aircraft has a natural tendency to just pitch down. So they're really difficult to stall. And that's, again, kind of a safety design. It's also a performance improvement in the aircraft, believe it or not. Those planes go very fast with very small engines. You can find planes like that, maybe 120, 140 horsepower engine, pushing almost 200 miles an hour. They're very sleek. They're composite constructions. I think one of there was the Easy Cozy, I think it was one of them. Bearcat was another one. But there was a lot of aircraft that were made with that type of design. And again, that's called a canard when you've got the little wings in the front. That's what controls the pitch on the aircraft there. Okay. Any questions? Great. And you already know about the rudder pedals. You guys are comfortable with that. Left rudder, you can see our rudder is going to bank over this side here. And actually, looking at it from here, this looks suspiciously like, if I zoom in just on this area right here, look at this, that looks like a cross section of a wing right there, and that looks like an aileron, doesn't it? See what's happening there? It's using the same thing. It's using the same dynamic forces, but instead of doing pitching like banking left and right, this is pushing. It's creating lift. In this case, it's producing drag on this side and lift on this side, so it's causing the aircraft to yaw to the left. It's the same as what it is on the aileron. If we do look at an aileron here, when this goes down, that wing is going to rise, right? Well, it's the same thing with the rudder. It uses the same type of thing, except that it's mounted in a different axis. That's how we control the aircraft. So it's, anyway, just want to point that out. So. All right, so this is kind of a unique aircraft. This is a Bonanza V35. And you'll notice that it doesn't have a horizontal or a vertical stabilizer or control surface. It has two of these V-shaped things. And what they've done here is they've kind of combined the rudder and the elevator into two of these surfaces. Yes?
There's a thing like that. There's a thing like that when we were leaving yesterday, or last week.
It was probably a V35.
And also at that, picture was the engine on top.
Oh, it had a Vision Jet? Oh, yeah.
Yeah, I was at this airport.
Gosh, do they have? Oh, they do have a canted. Yeah, the wings, the tail wings, or tail surfaces do rise up on the Vision Jet. It's not as extreme as this, if I'm not mistaken. But this one was, these were like, I think they started making these back in the 50s.
They call them VTOL.
VTOL, yep.
Is there a third wheel in the front there?
Yeah, you can't see it. It's
Yeah,
behind the
yeah.
main wheel right there, but there's a wheel right there.
Yeah, I was
These are-
confused.
What's that?
I was confused.
Yeah,
That's not
it is there. So yeah, it's buried in there. So what advantage do you think a design like this would have? Anybody want to take a guess?
probably pretty smooth.
Could.
Less drag.
Less drag, yeah, definitely. Look at here's a tail from a regular aircraft right there, right? You've got all these control surfaces out here, these horizontal stabilizer, vertical stabilizer. That's 3 surfaces. This now has just 2 surfaces. So you're producing less drag. So the aircraft performs a little bit, and that was one of their selling points. They said the aircraft, flies faster because there's not as much drag. Think of yourself as being wind. If you look at an aircraft, the front of an aircraft, let's see, let's go here. So they go to the front of this aircraft. All the stuff you can see right here is producing drag. So let's see if I can do this. So I'm going to fly. It's going to be hot weird, but I'm going to try to fly toward me. Okay, so let's push it down a little bit here. Okay, so I'm going to drop my flaps now. So that's producing a lot more drag there now. Those flaps are coming out. That's what the wind sees. What we're seeing right now is what the wind actually sees. And all of this is creating drag. Some of it's producing a lot of lift, but it's producing drag. So the more the wind can see as it looks at the aircraft, the more drag the aircraft is going to be producing. And that's why when we bank left to right, you've got those ailerons moving into the wind. They're producing drag. Okay, producing lift and drag. Anytime you produce lift, you're going to have that trade-off together. It's going to be producing some drag there. So, okay. All right. Different types of flaps. Again, I don't know if they really get into this too much, but let's talk about it anyway. So that's a basic cross section of a wing right there. The flaps, which I just showed you there, and that other screen there, if we go here. We can see these are flaps. I think they're pretty much fully down there, right here and here. That would be this surface right here. Now, there's different types of flaps. This is what is known as a plane flap, and all it is it just rotates, pivots up and down like this. There are split flaps, which actually come out from within a cavity in the wing itself. That's called a split flap. They produce a tremendous amount of drag because you still have that upper surface there, but you also have this flap coming down, and because of that, so I can draw this here. So as the air flows over this here, it hits this, and it starts creating turbulence there. The air hits this down here, and it produces lots of turbulence right here. Whereas in this flap, the air flows across and down like that. There's no, this right here isn't here because this whole thing is moved down in this position. So that's the advantage of a split flap, and we want to produce lots of drag on the aircraft. Let's see here. And then most aircraft have this, what's called a Fowler, or a slotted flap, or a Fowler flap. These are the most common flaps that you're going to see. So in this one, in the slotted flap, you can see here they actually show how the air, well, they don't show it on the top, and it pulls over the wing like it would normally. And then down the bottom, however, when it flows through there, it actually flows through a little channel right here and then down. So they actually produce a lot more lift and drag simultaneously. They're producing a lot of lift there with that. And then the Fowler flap, instead of just swinging down, see how this piece right here just goes from this position right here to this position? A Fowler flap actually has got tracks on it, and it actually pushes out from the wing. And we see this if you've ever flown on a commercial airliner. If you watch the flaps, they actually come out and then down. you seen that before in a commercial airliner?
I've never noticed.
Yeah, yeah. Next time you fly in a commercial airliner, just look at the flaps. You can see it on the training aircraft that we're going to fly. You'll see the flaps. They're on a track. They actually come back and then down. That's what a Fowler flap is. It actually extends it, and it gives it a lot more lift and some drag as well. So that's but it's definitely produces a lot of lift, and because of that channel there, it produces a smoother airflow over kind of like the slotted flap. But it's a little bit more efficient. See how sharp this turn is right here, where it swings and turns down. Whereas in a Fowler flap, it's a smoother turn, so it's going to produce less drag on the aircraft and more lift. Yeah, which is good for you if you're coming in for a landing or taking off from a short strip. Okay. And then the last one, this is a slotted Fowler flap, so it's got actually 2 flaps in it, and it produces even more lift. That's the one you're going to see on an airliner. This one right here. They pull back and then they extend out. So next time you're sitting on a wing of an airliner, have you seen it before? Have you flown the airlines? Yeah. It's you will go a lot. You'll see the flaps. There's like stages of them that go on. Hey Hal, how you doing? Let's see what we got here. Yeah, about another 10 minutes. Is that right, sir? Sounds good. Yeah, I haven't seen it. So let's see. All right. So, and then again, this is going to be for higher performance aircraft, typically, transport aircraft, like airliners and things like that. They have what they call slats and leading edge flaps and things like that. All of these devices that we're talking about, flaps, everything, are designed to do one of 2 things. They're designed to produce lots of lift and or drag, depending on the configuration. So in this case right here, this is they call it a fixed slot, but it's be considered a slat, I guess. So you can see here, this just pushes out in front of it. And you'll see this in a lot of airliners. They'll have this thing push out there. Again, it's designed to produce more lift on the aircraft. And again, when we come into land, especially when you've got an airline that's designed to travel really fast, you want to get it as slow as possible to come into land. So what they're doing is they're deploying all these different devices to get the aircraft to slow down and get it to a speed that they can actually land it. Because obviously, when they're at altitude, they're flying 400, 500, sometimes even 600 miles an hour. When they get down to the ground, they can't land at that speed, so they have to configure the aircraft to safely land, and they do that by using these different control surfaces on there. So this is a leading edge flap. Yep. This is going to produce a lot of drag right there. That flap is, and it's going to produce some lift as well. Again, leading edge slat or cuff, they call it here. We'll see many of those. Here, let's go up here. So this is a combination of 2 things right here. We've got Fowler flaps on this airliner, but we also have, maybe what those are? Spoilers, yep. Okay, so these are basically, they do exactly that. They spoil the flow of aircraft over the wing. And what that does is it creates lots of drag. You'll see these deployed when especially when they're going into busy airports. They got to get planes in, really fast on airliners. These big, huge sheets of metal come out. They're all hydraulic. You can see the hydraulics in there. They come up in the air and they spoil the flow of the aircraft. They also, in this case, these are fully deployed. This is probably coming to a stop on the runway here as after landing. So they deploy them on landing, and they're actually, in most cases, at least I know on the 737, they're auto deployed. So as soon as the aircraft touches down, it's got a firm contact with the ground. These all instantly deploy, and they create a massive amounts of drag. But you will see them deploy once in a while in the air, like especially when they have to get down really fast. They may not come up all this way here, but they be deployed there. And then obviously these right here are the flaps for the airliner. And you can even see this is a slotted flap right there. You can see another one in there, like another area there. So, okay. Great. And does everybody know what a trim tab does? Have we talked about that yet? Okay. All right. Let's see. It'd be nice if we could actually go out with real aircraft because I could show you what a trim tab does. It's hard to describe. Okay, so Jace, you're flying. Is it a 172? Okay, so maybe you can help us out with this. All right. So when you take off in the plane, are you constantly holding on to that the elevator to keep it at the pitch attitude that you want?
No.
Okay. What do you do to compensate? Is there something in the cockpit you use to adjust the pressures on the control unit?
Yeah. So if you're trying to go into a climb and you're having to pull back on the yoke, there's a little wheel down here that you adjust, which is your trim unit.
Okay.
And so if you're pulling back, if you're having to pull back on the yoke, you move the wheel back.
Mhm.
And so that moves a little wing on the back. It just takes out the pressures of the yoke.
Perfect. That's what I was looking for. Thank you. Yep. So what Jace is talking about there is when we fly, the aircraft obviously is producing various amounts of lift and drag and things like that during flight. We can, if we want to fly straight and level, we don't have an autopilot, let's say, we just want to fly straight and level. What we want to do is adjust the trim tab on the aircraft. And what it is, the trim tab is a small little wing like this right here. It's like the elevator. This right here is the elevator. And there's a small chunk of it that can turn in the opposite direction. And what Jace is talking about, he's got a control wheel in the cockpit that he adjusts the upward or downward direction of this little device right here. And what that does is it takes off some of the pressure on the control yoke, and you actually feel it in the aircraft. So let's say I'm flying straight level and the plane wants to climb. Well, I don't want to fly my entire flight holding pressure on that control wheel, right? I want to fly hands off. You should be able to fly an entire flight if you wanted to, from after takeoff to just before landing. You can fly the entire thing with just trim if you want to, and rudders. But to do that, you have to control those pressures, those control pressures. And what Jace is doing is he's adjusting it with that control wheel. It moves this up and down. Now, as we see here, the air flows across the horizontal stabilizer right here. It hits the elevator. That's what caused, in this case, that the plane is trimmed downward. But the trim tab is going up. What it's doing is it's hard to describe, but it's taking some of that pressure off. So in the aircraft, when you adjust that trim, what do you feel in the control yoke?
You just don't have to put as much pressure. If you want to go up, you should just be able to not touch the yoke.
Yep.
You want to go straight, like after an ascent, like say you stop at 2,000 altitude, and you should just be able to adjust it to where you want it, and then it should just be level.
Perfect. Okay. Yep. So that's what it's doing in the control yoke. It's taking off those pressures so that you don't constantly have to have your hands on the control yoke. It's just adjusting it there. So okay. All right. Anti-servo tab does the exact same thing. It's a trim tab. It's basically the same thing as a trim tab on a regular aircraft. And then if you look on aircraft, a lot of them will have these bendable tabs. It's kind of hard to see this right here, but this little piece of metal right here, you can actually walk up to it and bend it. You never want to touch it without a mechanic, okay? But you can actually adjust the trim of the aircraft with just this, but you do it by hand. You take like you can use these pliers and have these special grips on them, and you can actually bend it, or you can bend it with your hands. That will retrim your aircraft. So you got to be careful with it. You don't want to bend that piece of metal. And that's for fine tuning. This, in this case, is on the rudder, which can be trimmed as well. There, you're adjusting the normal flight characteristics. And again, what it's doing is it's producing just a little bit of lift in one direction or another to get the aircraft to fly, a little bit straighter for you. Okay. All right. And let's see. Adjustable stabilizer. We see this in higher performance aircraft. And so you can see it like an airliner. When you can adjust the horizontal stabilizer. So the difference here is that this is more used for like trimming a larger, like you call it your larger jet transports and stuff like that. The pilot doesn't control this with the yoke. They have a control in the cockpit, much like a trim wheel in a smaller plane, and it adjusts this whole surface. so that you don't have to necessarily have a trim tab here. Sometimes they have a trim tab as well, but that's how that works. Again, you're not going to see that in a small airplane. And last thing, this right here is a basic autopilot system. And what it is, this is what we call a servo, and you can see there's a little connection right here. These right here are push rods. They go probably to the elevator, I'm guessing. It's really hard to see. You really can't see it there, but there's like a little tiny linkage here. And this lever, this arm right here, moves back and forth. That's what's adjusting the push rods. This rod right here goes back to the elevator itself. So if this moves back to here, it's probably pushing the elevator up like this. And then if this moves in this direction right here, it's probably going to move that elevator down. And there's just a little motor in here. This obviously is a connection to the autopilot in the plane, but you'll see these boxes all throughout the aircraft itself. And so there's typically most small aircraft, they'll have at least, a lot of aircraft don't have any autopilots, especially training aircraft. They don't have autopilots. I know a lot of cargo aircraft, they don't have autopilots on there. So it's this is something you'll see though in aircraft that do have them. They'll have at least one. They call them axes. So they'll say, you'll hear pilots say, "Oh yeah, I've got a 3-axis autopilot," and really what they're saying is they've got 3 servos on the in the aircraft that control either the roll, the pitch, or the yaw. And in some case, they control other parts of the aircraft, like the yaw damping and stuff like that. They'll have an axis for that as well. And we're done with this session, guys. So that was fast. So today we've got Hal Davis coming in to talk with us. I'm going to go out. Let's take a 10-minute break, take a breather, and then come back and break more bathroom, whatever you need to do, and we'll come back and we'll have Hal Davis over here. You betcha. All right. Get this stuff cleared off for you. Okay.
I'll look at the main drone and stuff too.
Here. How's it right up?
Easy.
It's a nice day to be out. Yeah. So. Thanks, Skip. Yeah, of course. My pleasure. All right. Here. Oh. And it's like a bulk.
Yeah, should be the only thing on.
Okay. You good?
I think so.
Right. So does that look all right?
Well, let me see.
Yes, but everything else.
I don't know. I can plug in my laptop or.
Okay, it's up to you.
Yeah, maybe let's try that. I don't know. We got time.
Yeah, I don't know. Just gonna try it. I don't think this will affect it, but
I don't think so.
oh my god.
And now it's like, nah.
Did you have a regular? Do you have a regular usually my presentation?
I think so, on the website.
It's going.
I guess. Okay. Grab it.
Perfect.
Switch everything.
There's a camera right there. So I just consider it home. So, I think if you stand there from like right here.
All right.
To right here, then you can see it.
All right.
Also see this here, and then if you've got the.
Okay. Yeah.
All right, everybody, let's jump right back into it. The gentleman with me is Hal Davis. He is from the Wisconsin Bureau of Aeronautics. He's in charge of airport compliance throughout the whole state. He visits airports. There, I don't know, maybe I should let you talk about the funding side of things. So he'll talk about some of the stuff that he does as a career option, some of the things that he's into in aviation, and I'll let him go from there.
All right.
So,
Yeah,
thank you so much. Yeah,
Appreciate the
appreciate it.
opportunity.
Talk to everybody. I guess just so I kind of have a better sense of where you guys are at. Is most everybody in the room kind of thinking they want to be a pilot? Okay, cool. That's what I assumed. That's exactly like what I was thinking when I was your age. But what I want to do today is kind of give you an idea of some of the other careers that are out there that nobody told me about. And had somebody told me about them, I think it would have saved me some time and money and stress. But anyways, I'll jump into it here. Yeah, so again, thanks for having me here. Before I get into kind of the careers in the airport management and the state aeronautics, just a little background on myself. I'm from Appleton originally. Like everybody in the room, probably I loved airplanes as long as I can remember. I played with toy airplanes when I was little, flew flight simulators when I was a teenager, and then when I was in high school, I started learning to fly. I got my private pilot's license. This summer I graduated high school, went to the University of Nebraska at Omaha, in their aviation institute. That's where I went to college to get a 4-year degree. Let's see. Yeah, like I said, my career path was to be a professional pilot. But obviously I'm not here today to talk to you about my life as a professional pilot. That's not what I do. I'm not a professional pilot, at least not in the traditional sense. So like I said, I just want to make sure my point of being here is that there are lots of other career opportunities in aviation that doesn't necessarily involve being a professional pilot. Let's see. So yeah, I'm going to talk about airports, airport management and operations, how the Wisconsin Department of Transportation Bureau of Aeronautics kind of fits into everything, and then talk a little bit about my specific job. So, little class interaction. The FAA considers there to be 5 different types of landing facilities. How many? Let's see how many we can name. The first one's pretty easy and obvious. There's a rat one right now. Airport. All right. This is actually Reedsburg Airport. I don't know if anybody realized that, but little terminal building up there. All right. Second type of landing facility. So we got airports off the. So good try. Heliports. I don't know who said that, but perfect. All right. Well, they're getting harder and harder. The last 2 I don't expect anybody to get. So there's one other. It's a special type of aircraft that maybe doesn't need to land at an airport. Yeah, so what kind of aircraft lands? Seaplane. Seaplane, so a seaplane base. All right. And then the last two I'm just going to give you. You got ultralight flight parks. We have a few in Wisconsin. I don't honestly know that much about them because I'll describe my job in a little bit, but I mainly work with the public use airports. And then we have balloon ports, which we do not have any registered in Wisconsin, but I'm assuming, out west where they fly balloons a lot more frequently, it's probably where they regularly depart, because I don't think you can really decide exactly where you're going to land. That's my guess. All right, so, of those five, and I said we only have 4 in Wisconsin, airports, heliports, seaplane bases, and ultralight facilities. Take a wild guess, how many do you think we have in Wisconsin total?
3,000.
So I had 100 and 1,000, so that's perfect. Right in the middle, we got 546. So of those, 410 are airports. Well, here, actually, I can show you. So the red are the heliports. Those are mainly at the hospitals, right? There's probably a few that are not at a hospital, but mainly the hospitals. You got the gray is the airports. Blue are the seaplane bases. Green are these ultralight fields. So in 410 airports, of those, there's 125 public use airports. Those are the ones I care about, and I'll tell you why I care about them in a few slides when we get to that point. And then there are 93 publicly owned public use airports, just kind of like the one we're at right now, where the airport's owned by a municipality, a city, town, county, village. In Wisconsin, we have the red ones on the screen here. Those are commercial service airports, airlines. So Madison, Milwaukee, La Crosse, Green Bay, Appleton, Central Wisconsin, Eau Claire, and Rhinelander. Green is the large general aviation airport, so they serve anything but other than airline or scheduled passenger service. Blue is medium general aviation, and the gray is the small general aviation airports. And I mentioned those as kind of a segue into airport management, because every single one of these airports has somebody designated as an airport manager. And an airport manager's responsibility is to basically oversee the daily activities at the airport. So they might do things like conduct inspections of the airfield, report conditions to pilots. If you guys are familiar with NOTAMs and the notice to air missions, they call them now, notice to air missions, that pilots look at before any flight. Usually those are coming from the airport manager or airport operations personnel. They might remove snow in the winter, mow grass in the summer, make sure the lights work, help plan future airport construction projects, respond to safety and security events, and work with airport users and tenants like hangar owners. Depending on the size of the airport manager might do all of those things themselves. It might be a full-time position, it might be a part-time or even a volunteer position at the really small airports. Or at the large airports like the red ones we talked about, so the ones with airlines, they're going to have whole staffs of people, dozens of people that are responsible for some of these different things that we talked about. So my first few jobs in college and out of college were working at the Omaha, the Appleton, and then the Madison airport in airport operations before I started working for the state. And these airports, so the airports with airlines, have pretty extensive regulations that they're required to meet in order to provide a safe airport for passengers and aircraft. So they've got certain standards for painting, for lighting, for the pavement, and all those kinds of things. And so there's a whole group of people, individuals that are responsible for making sure that the airport is complying with those requirements. And so that's the airport operations folks, or airport ops. Let's see. So those guys, a lot of what they do is just inspecting airport facilities for problems, for issues, reporting and documenting those issues, and then making sure that they get fixed. And one of the key kind of components of that is regularly inspecting the airfield. So at an airport like with airline service, they actually are required to inspect the airfield, all pavements, at least a minimum of 3 times a day. And they might, I don't know how often they're going to tape measure out to actually measure how wide the markings are, but they are looking for things out there that could pose a problem to aircraft. one of those things, has anybody heard the term FOD before? Okay, so FOD stands for foreign object debris. And it's basically anything out on the airfield that shouldn't be out on the airfield. Think about trash that might have, blown in, things that might have fallen off an airplane. It's amazing some of the things you would find out there. A mower maybe got into some mud when they were mowing, they tracked it across the runway. Basically, all these things could pose a pretty significant hazard to aircraft, especially certain types of aircraft. When I was down at the Madison Airport, they got the fighter wing down there. It was F-16s at the time. Those engine air intakes are pretty low to the ground. They are like giant vacuums. So anything that's out on the runway, they're going to suck up. So it's incredibly important to make sure there wasn't anything out there. You guys have probably heard of the Concorde, the supersonic passenger jet. In 2000, there was a crash because on takeoff, it hit a piece of FOD, popped a tire, the tire fragments ruptured the fuel tank, caught on fire. Everybody, well, I don't know if everybody died, but it crashed, killed a lot of people. So FOD is an incredibly important part of the airfield inspection process. Unfortunately, another thing that you kind of find out there fairly often is dead animals, just like you see kind of on the side of the road. You do find animals that have been hit by aircraft. And unlike maybe on the road, airport ops or an airport should be looking very closely at what types of animals are being hit to see if there's something that they can do to try and prevent future strikes. So let's say you start finding a bunch of deer that could have deer strikes on the runway. Obviously, deer, that's a pretty big thing to hit. Bear, wolves, all these things, coyotes, all do get hit in Wisconsin. Fortunately, not on a super regular basis, but it does happen. And if that does start to happen, if they start to see a trend in an airport, one of the things you'll do is, especially for like land-based animals, maybe install a perimeter fence. It's a good way to kind of address that problem. Unfortunately, most of the animals that get hit are birds, and birds actually can, be fairly difficult to manage. Let's say you get raptors or something. Birds of prey are one of the common things that like to hang out around airports because it's a wide open space and they can see rabbits and mice and all that running around. So it's an easy targets for them. But by maybe reducing the amount of places they can perch, or if they can mow the grass so that the rabbits don't have as easy a place to hide, then maybe they can reduce the food source on the airport and they'll attract less birds of prey. Airports also have folks that trap animals and try and relocate them, or if need be, lethally remove them, I guess, from the airport. But anyways, as part of that process, it's really, like I said, it's really important to help try and identify what animal was hit. And for birds, that can be pretty difficult. A lot of times you can find, hopefully you can find some feathers that you can then send to the Smithsonian. Will actually identify the bird if you send some of the remains to them. You guys learned FOD. I'll teach you another vocabulary word, which is snarge. Snarge is what we call the remains of aircraft or of birds after they've impacted an airplane. So I tried to actually pick pictures of bird strikes that had very little snarge on them, but if you Google wildlife strike, bird strike, you're going to find some pretty gruesome photos. Obviously, the famous one where the U.S. Airways flight where they landed on the Hudson River after hitting some birds. So also as airport ops, a couple other responsibilities. Like I mentioned, you might mow in the summer, you might remove snow in the winter, but at a large airport, most likely you're directing these people where they need to go mow, where they need to go remove snow. You might not know at an airport, airport with airline service, they're actually measuring how slippery the runway is so they can report that kind of information. When I was in airport ops, we had a specific device in the vehicle and we would slam on the brakes at 30 miles an hour 9 times down the runway, 3 times at touchdown, 3 times at midpoint, and 3 times at the other end, the opposite end of the runway. and it would tell us what the coefficient of friction was. Now, a lot more airports have these continuous friction measuring devices that they just pull behind the vehicle, or sometimes they're incorporated into the vehicle themselves. But anyways, that kind of information is super helpful to pilots. They obviously, before you land at an airport, you'd like to know if you should expect snow and ice on the runway. That might change how you plan to brake or that kind of thing. So you might, let's see, at large airports, you're probably going to help respond to emergencies. You might be, in charge of the overall response, or at some airports, you might be trained as an actual firefighter yourself. I think Dubuque does that, and I think some of the smaller kind of airports that still have airline service do that. Let's see. Sure I didn't miss anything I want to tell you. Yeah. So anyways, airport management operations personnel need a lot of the same skills as a pilot and same knowledge as a pilot, but you don't need to be a pilot. Even though you might be in a truck or a vehicle or whatever, you're still most likely talking on the radio to aircraft or to air traffic control. So you need to have good communication skills. You need to have good situational awareness so that you're not causing additional issues out on the runways, out on the airfield. You need to be good at multitasking and have a strong understanding of aviation. So how aircraft are operating around an airport and in the airspace around it. And let's see. Yeah, well, I guess when I worked in airport ops and I was doing airfield inspections, I would almost always try and time it out so that if the fighter F-16s were taking off, I was right at the edge of the runway on departure. So they're as fast and as loud as possible. So other than being in the cockpit yourself, airport ops is one of the best ways to get up close and personal to aircraft, that's for sure. It's definitely one of the things I miss the most working. Now I work at the Wisconsin Department of Transportation, but it's definitely one of the parts I miss the most, working at the Dane County Airport at least. So with that, I'll kind of segue into what we do at the Bureau of Aeronautics. We're a relatively small group within the Wisconsin Department of Transportation. Most thousands of our coworkers work on road things. We're about 40 strong. We work on airport and aviation things in the state of Wisconsin. So we have somebody that does aircraft registration. We have somebody that does tall tower permitting. So if somebody wants to put up a wind turbine or a cell tower, we make sure that it's not going to have a negative impact on the airport. We talked about the wildlife hazard stuff. We actually have somebody in our office that helps airports all over the state on wildlife issues. We do training for pilots, for aircraft mechanics, for airport managers and airport engineers. But actually, the vast majority of what we do is all related to airport development, airport construction projects. So just like a road over time might need to be repaved or add another lane or whatever. As airports get busier or larger aircraft start to land at the airport, you might need to extend the runway or repave the runway. You might need to add more taxiways, hangars, fences. We talked about perimeter fences for wildlife. We might need to build a new terminal building, just like the one we're sitting in now. And so we've got airport engineers that are assigned to every airport out there, or of those 93 airports we talked about. Each has an airport engineer assigned to them that helps that local municipality figure out what they need to do at the airport, and then kind of works through the project process. There is state funding that goes into it. There's federal funding. The FAA helps pay for some of these improvements because it's really expensive to repave a runway. So anyways, that's what the majority of the folks in our office do. I do airport compliance, and so I'll talk about that a little bit. But before I do, one other thing I'll mention, we work very closely with the Federal Aviation Administration. I don't know how much you guys have talked about the FAA and all the different things they do, but I'm not going to get into it. But they're also another excellent source for careers in aviation where you don't necessarily have to be a professional pilot. And nothing against being a professional pilot. If that's what you guys all want to do, absolutely go for that. We need lots of pilots, otherwise the aviation industry doesn't function. But being a pilot is not without some drawbacks, and it can just be kind of difficult to get into. It's expensive, and for some people, it's just maybe for medical reasons or whatever. It might just not be in the in the cards for them. So if you like airplanes, you can't be a professional pilot in maybe a traditional sense. Just want to make sure, again, there's lots of opportunities out there to be involved in aviation otherwise. So let's all right. So yeah, anyways, back to what I do. So I'm the airport compliance program manager. What that means is I help airports understand what the various rules and regulations mean and how they need to comply with them. Think of me more as an educator than a cop. I'm not here to like bust an airport for doing something wrong. Most of the time when they're doing something wrong, it's because they don't know they're doing something wrong, or nobody's pointed out what they're doing is wrong or something like that. So as part of this job, one of my responsibilities is to go and inspect all those 125 public use airports in the state on a 3-year cycle. So every 3 years I visit every airport. Works out to about 40 airports a year, because I don't actually inspect the airports with airline service. The FAA does that directly. And as part of those inspections, or at least a big part of those inspections, is doing things similar to what the airport ops people are doing, or airport manager might be doing on a daily basis. I'm driving the airfield, I'm looking at the condition of the pavement, making sure the lights work. If there's spot, I'll remove it, that kind of thing. But a big part of the inspection is actually looking at all the safety buffers that are around runways. Just like if you're in a car, there's on a highway, there's shoulders and median and stuff, so that if somebody loses control or takes a turn too wide, they don't smack into a building or a tree or something right away. Pilots need a similar margin of error for what they're doing, and so there are safety buffers all over the airport. In particular, the approach surface is an imaginary slope off the end of the runway that allows that we try and clear so that pilots can make more shallow, stable approaches. They don't have to be like Luke Skywalker, diving through the trench of the Death Star to try and get to the runway, right? You can just, as anybody that, has done any flying, you want to have a nice, stable approach into the runway. That's going to be the safest. And so we try and give airports, by looking at these surfaces, we try and give pilots better margin of error. The traditional method of identifying, well, actually, I want to show you first. So when I'm at an airport, so I did bring some tools. The traditional method of kind of like looking at for obstructions is to use my laser rangefinder and my iPad here. Here we are. This is live. Here we are at Reedsburg, and I've got all these different surfaces I can look at. So we got primary surface, runway safety area, runway object free area, their state approach surface, FAA approach surface. All these, you don't need to know what any of that means, but these are all the different surfaces. They all have different standards, and so these are the things I'm looking at. And when I drive around or walk around an airport, I can follow myself in the blue dot, and I can see where I am in relation to some of these surfaces. The traditional method of using the rangefinder and the iPad, really easy, really good way to quickly identify if there is a problem, but it does have some limitations. So one being I'm on the ground, I'm limited by my line of sight on the ground. So perfect example here, this is actually looking out an approach area at the Wild Rose Airport. And this is a pretty extreme example, but pretty much every tree in this photo is an obstruction and shouldn't be there. So using these traditional methods, I can tell the airport manager, hey, look, you've got a bunch of trees that are obstructions. Everything I can see should be taken down. But that's not the full story, because that's obviously, you can see here, this is just the start of a forest off the end of the runway. And so I can't really tell, using these traditional methods, I can't tell an airport manager how far into the forest they need to go to move trees, or whose property the trees are on, that kind of thing. So it came to my attention a few years ago that other states have started using drones to do airport inspections. So about 3 years ago now, we purchased the DJI Phantom 4 RTK. previously, if you wanted to inspect an airport from the air, you had to hire an airplane with expensive equipment on it, and that was very expensive. And we still do that in certain cases, but this drone has been very helpful because we can basically offer a very similar service to airports for free. Basically, we don't charge airports for my time to use to do this. But anyways, we bought a DJI Phantom 4 RTK. Let me just look at my notes again. I guess, has anybody in here flown a drone before? Or has a drone? All right, so this drone probably looks very similar to any other Phantom, DJI Phantom. The only real difference is this little module at the top, the RTK module, and I'll talk about that in a little bit. But otherwise, it flies pretty much the same. It's a purpose-built for mapping, so that's one of the reasons we bought it. And it also came with a mobile station, which is in the photo there. It's on the left. So that, well, I'll talk about that in a minute. So generally the way the process works, or what I do with the drone, kind of starts the way any drone flight should work, doesn't matter how you're flying it. First question you should ask yourself is, can I fly this mission? So hopefully a lot of you guys know, if your drone pilots have a drone, the FAA has very specific rules about how you can operate a drone, depending on how you're using it. So for us, we're flying a drone for non-hobby purposes. That means we have to comply with FAR Part 107, which requires me to be a remote pilot, certificated remote pilot. I got to look at things like airspace and weather. We can't, let's see. So we can't fly over people because or vehicles and cars, or people in cars, because of Part 107. So if there's like a busy road in the area I want to try and survey, that could pose a problem. We'd also, generally you can't fly at airports with air traffic control towers. There are waivers and things you can do, but for the most part, we don't do that. And then I just look at, weather. What's the winds? Is it going to be too windy? Is it going to be too cold or too hot, I guess? Is there, they call for any precipitation? So just like you do if you're a manned pilot, I'm doing a little bit of a flight plan here. Visibility, I have to keep the drone within visual line of sight, just like anybody else. But if the mission looks like it's something I can do and stay within compliance with the regulations, the next step is mission planning. That controller has some built-in mission planning tools on it that basically I just tell it where I want to survey and then put in other parameters like overlap with the photos and that kind of thing, and it spits out a flight plan for me. The yellow lines are basically the flight path that the drone's going to take. There are two different mission types. You got a 2D and a 3D mission. 2D, the camera points straight down, just kind of flies back and forth. Really good if all you care about is capturing like an overhead 2D image of an area. 3D, the camera tilts down at like a 30-degree angle, flies on a crosshatch pattern, and that does a much better job capturing the 3D data. The planning software will tell me, my estimated flight time. That way I have a sense of how many batteries I might need, how many photos it's going to take along the way. Once on location, I set up ground control points. These are black and white targets. They're like 2 feet by 2 feet. And those are used, we precisely identify where that is. We put a GPS unit over it, so we get coordinates of that. And then when we go and process everything, we can add those in, and the software will automatically kind of help calibrate the image and the data so that everything is super accurate, super precise. But otherwise, once the ground control points, so I usually do like 3 or 4 of those. Once the ground control points are set, then really the only other thing to do is set up the landing pad and the drone. I'll do a quick run up. I can real aircraft, making sure everything's operating correctly. But otherwise, it's really, I've done all the flight planning. I just push a few buttons and the drone takes off and flies everything autonomously, takes hundreds of photos along the flight path, and lands without me having to do anything. But I'm there just monitoring mission status, battery levels, looking for potential conflicts with aircraft or with birds, and just ready to take over as needed. Since I'm operating on an airport, I do make regular radio calls to notify traffic in the area that the drone might be flying off the approach end of runway 18 or whatever. Let's see. Well, missions take anywhere from like 10 minutes to like 45 minutes. Most take about 25, 30 minutes of flight time. And yeah, just during the flight, real-time geopositional corrections are provided to the drone via the mobile station on the ground I talked about. Your phone or iPad or whatever probably has a GPS unit, so does the drone. The problem is a standalone GPS unit like that probably has an error of like plus or minus 15 feet, which is plenty good if you're just using Google Maps to like get directions to the Reedsburg Municipal Airport or whatever. But for what we're doing, we want much higher precision, and so that's where the mobile station comes in. Is that the two of them talk to each other. The RTK stands for real-time kinematics, and I'm not a surveyor, and you don't really know exactly what that means, other than somehow this setup where you have one rover and one stationary GPS unit that are both talking on the satellites and talking to each other and correct for common GPS errors and give you like sub-centimeter accuracy versus that plus or minus 15. So anyways, once I'm back in the office, I take all the photos, put them on the computer and run them through a program called SiteScan. There's a few different similar programs out there, but what it does is just stitches all those images together into both a 2D and a 3D model. This is actually that same runway at Wild Rose again. You can see the 2D orthomosaic, we call it, superimposed over just satellite imagery. And then on the right, the 3D model, you can do some kind of basic measurements in SiteScan itself. But for the most part, I'm exporting it to another program so I can do a little bit more elaborate analysis. So these are some examples. This is one of the runways up at Washington Island, and then all the runways up at the Cable Union Airport. These are pretty extreme examples, but basically all the red, those are obstructions. Those are trees that shouldn't be there, they should either be removed or topped. And then orange is anything within 5 feet of becoming an obstruction, and yellow is anything within 10 feet. Generally, we tell an airport anything within 10 feet should probably be removed. Otherwise, because if you remove just the obstructions, trees grow, and so every year you're going to be back doing the same thing over and over again. So you might as well do everything within 10 feet, and then hopefully give yourself maybe 10 years before you have to come back. So these are pretty extreme examples, especially cable. But anyways, those are some examples of the sort of maps we make for airports. And this is that same runway again at Wild Rose, where you can see on the left the 3D model, the approach surface kind of going through the trees, just to kind of better visualize the issue, and then another map on the right. So this has some pretty obvious benefits over just my, shaky hand laser rangefinder. Accuracy is improved. It's a much more comprehensive survey. I can look at the entire approach area versus just what I can see from the ground. And then we can make these cool and helpful maps as well. So yeah, since 2021, when we bought the drone, I've flown it at 71 different missions on 35 different airports with it. And then due to the capabilities of the drone, we're actually looking at using it for a few other things on the airport as well. One in particular is airport pavement inspections. Like as we speak, there's been so much, there's so much development going into using AI to automatically analyze pavement, like kind of the same kind of data that we've been looking at. But if, let's say, you fly over the entire runway and now you've got a picture of the entire runway from above, you can have AI identify where all the cracks are versus somebody driving down the golf cart and doing it on a little map, which is traditionally how it's been done. And so that's a much faster and more precise way to look at pavement conditions. You can use it to haze wildlife, monitor construction projects, all sorts of things we're thinking about using it for. Elsewhere in DOT, they are using it for similar things. So we've got the DOT, like inspectors, the highway inspectors are using it for monitoring pavement, looking at bridges or inspecting bridges and other structures. State Patrol uses drones for search and rescue and all sorts of other things. They're looking at doing it for doing like crash scene modeling with drones. But in general, drone mapping is a super fast growing facet of like the drone industry. So you know, just think of any industry where it'd be helpful to have a digital model of something. You got utility companies that have massive amounts of infrastructure, transportation companies, that kind of thing. You can monitor, you know, infrastructure condition with it, and like we've talked about, you can do measurements with them. Volumetric measurements, for example, is super helpful. You think of a quarry, or you think of a landfill, where you could survey the landfill, survey the quarry, have trucks come in here and remove material, or trucks come in and dump trash or whatever, and then you survey it again, and you can actually measure the difference in volume. Something that would be almost impossible to do by hand any other way. I think they usually use weight, but using drone technology, you could actually do some pretty cool volumetric analysis. Agriculture is another emerging use application for drones. Imagine how useful it would be for a farmer to have regularly updated scans of their entire fields. They can see, where crops might not be growing well. Maybe it's too wet, too dry. And then using this, they could then pinpoint exactly where they need to water more or spray pesticides or whatever, rather than spraying the entire field. They can do much more precise treatments, and then, refly it or whatever. So for anyone interested in a career in flying drones, in addition to manned aircraft, or, separate from manned aircraft, definitely check out drone mapping. I know there are programs in the state at colleges that you can get a 4-year, I don't know if it's 4-year degree, but you can get a degree in, being a drone operator, and I know they focus on mapping as well. So anyways, hopefully that wasn't too long, but happy to answer any questions on anything. Talked about airport management operations. Yeah.
I wanted to know what your vision was.
Yeah, it was, I think they called it Air Transport Administration. At the time that your major was either pilot or other in aviation, and I kind of was that was what they called the other category. So I think now, and it also depends on the school. So Embry-Riddle, UND, they're going to have airport management like tracks, if not an airport management degree at the end of the day. I think things have come a long way since I went through the process, but yeah, anyways.
Your photos.
Yes, in the sense that I took all of those photos. In my job, I know all the airport managers, so I convinced Oshkosh airport manager to let me sit next to the runway on the Sunday before AirVenture back in 2019, and I took pictures of every airplane that kind of landed, and then did my best to composite exactly where they were. That together. So
That's actually cool.
Thanks. I love that. I just see that. Yeah. I saw that. I was like, that must be.
yeah, you can see the tower. Yeah. One of the parts of the agenda. Anything else?
So I do have a couple questions on like, so obviously you've worked with Reesburg and Baird on getting us like funding. Do you work with the FAA to help get like the funding for the airport?
So I don't personally, but I can answer your question. So the Bureau does, and I don't know. I didn't want to get into this because I don't know how technical people care about it. But so the state of Wisconsin is a block grant state, which is a fancy word for meaning a lot of what the FAA normally does in other states is delegated to the state of Wisconsin. And so in Iowa, for example, they are not a block grant state. They don't have somebody like me that's going and inspecting all these airports. Instead, FAA is doing it themselves, or if they are hiring somebody, a third contractor to do some of it. And they don't have engineers that are necessarily assigned to every airport. Instead, FAA is doing a lot of those things themselves. So in Wisconsin, as a block grant state, yes, we're working much more directly with the airports, and then kind of as an intermediary between the airports and the FAA. But the FAA is definitely still very much involved. And that's I guess it's another point I wanted to bring up is this is how it's done. What I give you was an overview of what's done in Wisconsin. There are other states that operate very similar to Wisconsin, other block grant states specifically. I think there's like 15 of us out of the 50. But then how other states operate, to be honest, I can't even really tell you. Every time I talk to another state, they're doing things completely different. We're still doing the same thing, but how we're structured and how we're getting things done is completely different. But what I guess want to make sure you understand is that there are people in every state doing these similar things. Some states, it might be a dozen people. In states like Wisconsin or Texas, I think is a block grant state. I assume Texas probably has 100 people maybe working on aviation, whereas we have 40. So it just depends. But anyways, lots of opportunities out there for again, people that want to be around airplanes. And some of us are pilots. Like I said, I do have my private pilot's license. I still get to fly occasionally. I take all those aerial photos. I fly with our chief pilot. He usually flies, and I hang out the window at 1,000 feet with my camera and take pictures of airports or highway projects or whatever. So I still regularly get to be in airplanes, but it's not the focus of my job. So yeah. Jody, I don't know if you had any more questions.
I have a ton of them.
Okay.
It's some of the questions I have.
Anybody else? All right. Cool.
Thank you very much.
Yeah. Thank you.
All right, guys. So session 7 next week. I think that's aircraft systems.
So the 4 of you, I guess over here that haven't met yet, and you step in, but if you guys come on, I'll give your email address and send you the info about how to sign.
It's very least if everybody becomes a pilot, I think they got a little bit more appreciation for some of the behind the scenes stuff that happens, just to make sure that there are airports to land at. Yeah, I don't know. It's a fun job. And I'm lucky in that I'm the only one that does this in my state, so I get to go to all the airports. It's a lot of fun. Other states like Minnesota has a little team section of the state, but they're also, Minnesota might regularly inspect all their private facilities and airports and stuff. We don't have a requirement to do that. So anyway, yeah, it's definitely a very fun job that I had no idea existed until I was graduated. And yeah, I was doing the airport ops. I thought I was going to be an airport manager someday. State job opened up.
Yeah, that's excellent. Yeah, I remember Tom Thomas. Yeah, I knew him back when he was working there.
Yeah.
Super helpful.
Yeah. So Tom would have been. I know Tom. I've met him many times. He would have been the section chief for my section. Yeah. So the guy, I don't know. We've also kind of changed who does what for the years, but like John Dorsey kind of would have done what I did, what I do now. Tom Thomas was there, and then we had Scott for a while. So now we got Max as the current section chief. So yeah. Anyways, yeah, that's it's pretty cool. It's fun to go.
Yeah, I'm looking forward to seeing. I'm going to see Olivia on Thursday.
Okay.
At the Chula Vista, WTE.
Okay.
Doing a presentation. We got a booth up there.
Cool.
They gave us a booth. So looking forward to doing that, and then meeting obviously with her. And then next week she's coming.
Good. All right.
So really appreciate
Well,
you guys.
hopefully that's still too much.
No, that was perfect. That was perfect.
Yeah. Yeah. I know she's got a lot to talk about. I mean, she's always got flight attendants.
Oh yeah.
Yeah. So she'll be good. And then she can hopefully talk about some of the other maybe aviation education stuff. She does have opportunities around the states.
Yeah, fantastic, fantastic. All right, sir. Well, listen, I'll let you go here, and thanks again for.
Yeah.
We really do appreciate you taking the time to come up
Yeah,
and talk.
my
with
pleasure.
everybody. So it's we have a lot of interest. Just never know.
Yeah. Yeah. All right. Well, it was fun.
Yeah, you take care of that. Hal.
Thanks. Yeah.
Oh yeah. Yep. All right. Let's see. Let's just need your information here. Oh wow. Are we getting everybody's cell numbers? You're comfortable with it? Yeah. Then that way, if something does happen, normally I can just on the transfer.
Yeah, 608. 7.
Thank you. Very interesting. I don't think many people know what we do or we even exist, but that's an opportunity to tell some people. So I work. That's enough for me to get back to that.
Yeah. Oh, yeah.
Let me give you my email address.
Yeah.
Yeah. If you have any questions, email us. Yeah, it's just. And then, the website people might get on for the educational materials, basically follow and just register on that site. I think there's like a code for the class. If you want. I'd say let's send me an email first, and then I'm gonna send you the email that I sent out.
Okay.
And then we'll just click on the link there that will take you to that site. Existing, and then you'll get registered on it. Have all the training materials, just tons and tons of videos. They're the actor rated and everything. So they come from all just like top. They're really helpful. So you don't have to do all the, if you really understand the concept, just move on. It's when you get stuck on something. And obviously, if you have questions on something doesn't click. I don't always communicate things effectively sometimes. It's the person, if they understand it, or if I don't. But again, just talk to me. If I can't explain it, I'll find something.
Okay.
Right? So thanks for coming. Yeah. And then your kit. I'll bring you a kit next week. Okay. Yeah. Okay. I'll bring your kit. That's got your 6D. It's got your training board. A bunch of other stuff. Federal aviation regulations. So there's a process. So thank you much. So it's not broken. It's he described it. So we did the inspection. Everything is working fine. It's just waiting for it's called flavor. So I'm still plans at this one. As this one it's always coffee. It's a heater that I use. It's in the flag, so there's no them in the content, so it's cold there. So what they do is they actually use heaters in. It's a coffee can size heater, and they have to inspect it every time they do that. If you miss it, that helps them inspect it when they do, because they put a ball in the they'll pump it up and then they run the heater to see, to make sure that it shuts down. Because if it doesn't, that means it could get out on the flame. That's my point. It's like, I'm sorry, it's just like somebody being dead matching these balls, and there's all the mechanics across the vessel for testing. So anyway, I said, okay, well, what can you do? Is there anything else? I said, okay, I can flatter it. So that's what he's in the process of that. So that means that next weekend we've got now if you wanted to. I can still meet you tomorrow. And I can take the plane out. I can start it up. Later on, I'm not flying yet, so I'm whatever. I need to show you some things. I've got to do anyway. I've got to test this everything. But we just can't fly. And then I can actually tell you that it's the things out there. I'll start those up, you know, and make sure it's fly on. Actually suggest it. Otherwise, you don't want to do that. It's totally understand. We can shoot for it. So it's the key. All right. So what time tomorrow? Okay. All right. That's good work. So you know, okay, yeah, you can. Yeah. Okay. So go park at the same place that we have where the SIA office is there. Just park there. I'll teach you. Go through the instructions. So try to be able to. All right, and then that convention is Thursday. So if you do want to make contact, that's great. That's actually good stuff. So you deal with them. Let me give you my cell number. When you get there, they may say, "Oh, well, you got to pay to get in," and we were invited there, so it doesn't cost us anything. So. So you can just text me. So you can text that. They're in the help that you're all having. Since it should look as if you can make it, you know, and then projects and teachers and focus and questions and stuff like that. It's nothing else. I'd like to see that. Got some people that are involved in this. So it's crazy. I'll see you tomorrow.
Josh, I got a quick question. You know where I can buy any of the hats that sold that you get?
Oh, yeah, I got a ton of them in here. Can you send me just tell me what you need. I'll make sure I bring it.
I just need like one.
What? Okay. Did you get one?
I got one originally. I just need one because I did use that for welding, so it's all. So I just wanted to have one that I can carry around.
Absolutely. I'll just bring it. If you remind me, send me an email. I'll just.
All right, thanks.
Or next.
Yeah.
So, yeah.
It's nice meeting you. I got the other emails from the others.
Yeah, great. Excellent. So thanks again for.
Yeah, absolutely. Can I help you with anything in the room?
No, I've got everything now. I've got everything
Yep,
down.
perfect.
I just shut everything down. And now I've got stuff, of course. I thought we were done. Giving up kids.
Yeah, I know. I got a nice thing with her. Yeah, so she's been flight training. Oh, great. Yeah, she's been flight training where she started in the fall. So she went to Lori and then they left. And now she's with her. So she's already experienced and she's pre-self. She's experienced already.
Oh, wow.
Anyways, she's coming along. I encouraged her that no matter what, stick with it. We need you 7%.
Yeah, absolutely.
You know, and that if I can learn it, you can learn it. So she's, you can tell she's really invested. So many of these kids are interested in Air Force. Yeah, maybe it's just in the teens think Air Force because they just think cool flying.
Yes, I would. I was that age.
Yeah.
And the thing is that each gets it.
Yeah.
The chance to experience some of them. Your one student.
Yeah.
At least they expose it.
Yeah.
Class is done. I do see. The mics open up. When they
Yeah.
use it. Especially with speakers.
So Jason started coming on Thursday night ground. So we have a Thursday night that we take a lot of the ground from before and after lessons.
Yeah.
That we're doing in a group setting. So that you're not learning all this information right before you go fly.
Yeah.
You're refreshing it
Yeah.
before you go fly.
That's great.
So.
Yeah.
And so Tim as well really likes it. He's like, this is smart. This is good. And you have time to dig into things more. So Jason's been coming to that and then getting the scholarship. She has to be finished by the end of Spain because she wants to be set up to go to the Air Force there in June.
Oh my gosh.
And so I said, you stay home and you start on written test prep.
Yeah.
So keep going to Joe's group and then in addition, start doing this. And so that's what I need, because then I need to written done by hopefully the end of May.
Yeah.
That then
She'll be ready to
Like
take it
this summer.
Yeah. She's.
Yeah. 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 Yeah.
And maybe they absorb it, but I couldn't.
This video, I was noticing most of the kids you don't look totally right now. I was not saying has been repeating this and yes.
Yeah.
Yeah.
Yeah, I see it. I should,
Yeah.
John, the outside, I can see all the test scores, chiefs. At least,
Great. Yeah.
and I told him, I said, okay, what's.
You choose like.
And hopefully.
Yep. Yeah. So this is what I'm talking about with like, and because of your donation, we were able to go ahead and get ordered the laser engraving
Oh, great.
by getting that those funds back that we
Yeah.
committed. And so our Tuesday night, twice a month, is already expanded. And so it's just wonderful to partner like this. with
Yeah.
each other.
Yeah.
And Tim and I will get back over and we'll
Yeah.
delve into that simulator.
Absolutely, yeah.
We'll have you show us some stuff and then we'll just take some time.
Yeah.
If it's okay, and
Absolutely. Yeah.
I'll let him learn it. I mean, so,
I think you'll like it, once you get into it. So the problem, I shouldn't have shown it to you. Just did everything.
No problem.
It's just a mess.
no problem.
Now it's just like.
Okay. Oh, what ATD one did you get? How much did it cost? What, is there a brand name? What'd you get?
So I have a basic
Yep.
ATV, that's the Glide. I
You
think-
went with the Glide one.
Yeah, the Glide. It's the least expensive.
So I researched Glide. Oh God, I wish I could remember the brand name I'm gonna buy. Anyways,
Redbird?
it's 20,000, yes.
Yeah.
It's the basic Redbird one. And that with all the add-ons, I'm gonna get the $20,000 package.
Yeah.
So it's just a matter of timing this year when I do it, for sure by the fall, so that we can then, going into the winter months, have that all ready to
Yeah.
delve into it in between bad weather days. And so, yeah, I want to come over this year and get used to yours.
Yeah.
We'll do that. And then,
I think what
Yeah.
you see is, what I'm doing, what I show you is the experiment. I
Okay.
designed it myself.
Yeah.
I built it like older, so I.
Yeah.
Very comfortable. I said, and she knows enough about aviation.
Yep.
Situations.
Yep.
Not just
Yeah.
feel management. Or
Yeah.
just, she'll like, feel, feel,
Yeah.
or maybe a filter or something like that, or she'll do combinations at will gauge, then, she'll break, she'll pop a certain break or something.
Yeah.
And it's things that happen in real life,
Yeah.
it's like, so, and then she can change the environment, and whether it takes like 2 minutes or something like that. So,
Yeah.
by a fire.
Yeah. Yeah,
So
that's
it's
great.
really.
That's super. I'm bought. I'm sold. You sold me now. I'm like, we're always meeting, because like if we can't literally go up, we'll do it, okay, what I want to show you is about your steep turn.
Yeah.
So I'm trying to let you just see when your nose is dropping.
Yes.
So let's take a look at this.
Yeah.
What
it's-
is supposed to be happening right here? Oh,
It
we're
is.
supposed to be pulling back on the yoke. Okay,
Yeah.
that's exactly right.
Yes.
To help them see it and get it.
Those are, did you see my explains?
No, I didn't.
Yeah,
Yeah,
it's,
I was-
it is great. I got some really good tools for
Okay.
use for that. So
Perfect.
I've got that's an inexpensive stick. It's like $130.
Okay.
But it's what I did is I controls for an instructor.
Yep.
To switch to the outside view.
Yep.
And so you can actually see the control surfaces. I can switch to that. So you can,
Yep.
or something like that. But everything also shows the flight. Use that all the time. So there's some tips and tricks I can show you under that help illustrate some things.
Okay.
Or it's more for instructing on a here in the classroom, but it was great for learning, especially.
Okay.
Stuff like that. So we've got time. I'll
Yeah.
show it to you because it's
Yeah.
really, I think so for me it's a game changer when it comes to some
Yeah.
topics in the past. It's always been holding that up. I still use that model, but it's so much easier showing. They want to see something.
Yeah,
That's
correct.
it's realistic.
Yes.
Anyway, yeah. So
All right, well, we'll get a hold of you in the next few weeks here,
Okay.
as soon as we know whether makes sense. I'll shoot you an email and say, stay with.
all right. So
Thanks, Joe.
thank you so much for
Yeah,
that.
have a
You
good
take care. Yeah, you too now.
Well, the party's over.
Yeah. Done.
Party going to take.
Excellent. Just this group of kids.
I have that big,
What's that?
that fellow left in that big suitcase like